We're going to look at how to factor completely, looking at only the ones that have fourth powers here, just because these can look really challenging. So we've got q to the fourth plus 5q squared minus 36. So I want you to think of this like q squared plus 5q minus 36. It's very similar the way that we factor this. We got to think about what multiplies to negative 36 and what adds to 5. And the q are going to go here. So negative 36, you could do 9 and 4 because those are 5 apart. It's a positive 9 and a negative 4 because it adds to a positive 5. And the only difference is we got to get it to q to the fourth, not q squared. So we're going to change those q's to make them q squareds. Then if you multiply this out, you're going to get q to the fourth plus 9q squared minus 4q to the squared minus 36, which gets you back to the original, q to the fourth plus 5q squared minus 36. So that does work, but we're actually not factored completely enough. We have to keep going. If you look closely here, one of our factors is actually a difference of perfect squares, so we should keep going with that one. This q squared minus 4 is actually q minus 2 times q plus 2, if you just ignore the left side for a minute. And then we're going to copy that left side down because we still actually need it in our final answer. So that would be our completely factored form of this trinomial, which you can see here on the left. Let's try some more like that. Let's try this one. So this is g to the fourth minus 14g squared plus 48. So we're going to use g squared in each of them. We're going to multiply to 48 and add to negative 14. So this one, let's think about this one. So multiplying to a positive and adding to a negative means that both of them are going to be negative. So this is going to be 6 times 8, but both are negative in order to multiply to a positive and add to a negative. These are both differences, but the 6 and the 8 are not squares. So we actually are not going to keep going with this. This would be factored completely because the 6 and the 8 are not a perfect square. So that one should be done. Let's try some more. Let's look at this one. So x to the fourth minus 6x squared minus 40. So again, very similar. We're going to use x squared in each one. Multiplying to negative 40, adding to negative 6. So multiplying to a negative, adding to a negative means we're multiplying with one negative, one positive. This is going to be negative 10 and plus 4. This one is going to be completely factored because 10 is not a perfect square for that difference, and 4 over here on the right is not a difference. So we're going to be done with that one. Either order is obviously always fine. Let's try this one. So this would be h to the fourth plus 13h squared plus 30. So it's going to be h squared in each part. Multiplying to 30, adding to 13. That one's pretty simple. That's just 3 and 10. And then again, there's no difference of perfect squares, so that one's also done. Let's try this one. J to the fourth minus 3j squared plus 2. So it's going to be j squared in each part. Multiplying to 2, adding to negative 3. So it's going to be a minus 2 and a minus 1. Which hopefully you can see. Got to go one more step here. J squared minus 2 is not a difference of squares, but j squared minus 1 is. That'll be a j plus 1 and a j minus 1. And of course, any order of those is totally fine. Let's just do one more here. Well, that one actually would have been a good one. I should not skip that one. Let's try this one. So d to the fourth minus 49. So that'll be d squared in both parts. And there is no middle terms. We're adding to 0, so we're multiplying to negative 49, but they're adding to 0, which means 1 is positive 7, 1 is negative 7. 7 is not a square, so that one is also done. Maybe I'll do one more here. Q to the fourth plus 5q squared minus 36. This one seems similar to before. So q squared plus 9, q squared minus 4. But then the negative 4 there, the minus 4, we can make into another step because it's a difference of perfect squares. So q plus 2, q minus 2. There we have it.